So hello, I'm Lisa Harnett, and I'm the host of the AWS Cloud Financial Management Talks. But today I'm here to introduce Rick Oakes, who will be talking about choosing the right tools to optimize your AWS costs. He is our principal product manager around the AWS cost optimization, but he's been working in this area for over 10 years, or just around 10 years. We were talking about it earlier, but if he had been with AWS the whole time, he'd be a red badge employee, but he's been with us for a little while now. He's worked with a couple other companies as well. And this is a version of the talk that he gave at reInvent this year. But there's a lot of great insights, and I'm really looking forward to being able to share or hearing how he goes today and take your questions as we go. So with that, I want to hand it over to Rick. Thank you so much for being here.
Thanks, Lisa. I appreciate it. And thank you, everybody, for attending. I'm looking forward to having a nice conversation about cloud optimization methods, and excited to take your questions and have a conversation about it as well. So thank you for joining. So we're going to address a few different topics today. Some of the questions that might pop up or you might have relating to where do I begin? I think those poll questions were really insightful as far as where in the journey you're at. What tools can you use? What methods can you use? These are the sorts of things that we want to address today. So I think the poll results are timely and on topic, so I'm excited about that. So the agenda for today, we're going to start with the visibility journey. We're going to talk about optimization methods. We're going to talk about Compute Optimizer, the AWS product. We're going to talk about specific recommendations for right sizing with EC2 and also EBS volume recommendations. We have a few other things sprinkled in throughout the agenda as well, in between the cracks. So we'll get to it, and I'm excited about hearing your thoughts as well about optimization and where you're at and what tool sets and what methods you're using. So feel free to chime in the chat on that. Okay, so let's talk about the visibility journey. So this is an experience we've had with a lot of companies and across a lot of organizations, where when you begin moving to cloud, whether that's maybe an organizational commitment to be cloud native or maybe a lift and shift migration, it really starts out fairly chaotic because it's very difficult at times to choose which service types you're going to standardize on, which templates or instance sizes are important to you, how to do governance. These sorts of things can be really sort of difficult from the beginning. And it slowly turns into awareness as maybe you have subject matter experts in your organization that sort of step forward, get some certifications or training. You maybe roll out an application in production on cloud and begin to have some of those lessons learned about production operations and management of resources and things like that. And as this maturity journey continues, you get to the safeguards phase. And this is really where you are starting to implement security best practices, and your security organization is getting involved. And you're finding that different resource types have different security mentalities. For example, your on-prem security might have been focused in on networking, whether that's securing the over the wire or the port, whereas in the cloud, it's definitely more of a granular security capability. And so kind of addressing that and changing security to be a little bit more focused on what cloud is capable of can oftentimes let organizations really take a big pause here in their journey. And then once we have safeguards sort of addressed or at least on track, it goes to governance. Governance is a crucial step, especially for optimization. This is critical because we have to understand which resources are owned by which parts of the organization. Do we have naming structures for our workloads, for our accounts? Do we have a tagging strategy? How do we understand our bill broken down by organizational boundaries? And governance, it's like a never-ending game because we're always chasing and increasing the accuracy of the data sets. And we need to be able to see our bill in different ways that are broken down by how we as an organization think and use cloud resources. And then lastly, optimization. Now, the reason why optimization is kind of last is because it's really difficult to optimize your cloud spending if you don't know who owns what resource, if you don't know which are production resources versus non-production. And so it makes it kind of difficult to take action and execute cleanup activities, right, without clear ownership and accountability for the resources. So that's why the governance component is before optimization. And this is interesting because optimization, unfortunately, is last. But there are opportunities to have optimization activities or best practices apply earlier in the journey. And we're going to show you some of the tools and ways to do that. So take a look, wherever you're at in this journey, whether it's visibility or cloud maturity journey or whatever you want to call it, wherever you're at in this journey, definitely take a look as we talk about the tools and capabilities about how they can be done before you have governance potentially. Or maybe if you're partway through your governance process, maybe we can apply optimization to save areas like non-production or things like that. So, okay, so now we talked about optimization being the sort of last step on your journey. Let's talk about what are the methods to optimize. So typically we think of optimization as 4 main methods to save money without hurting performance. The first is discounts, and that's purchasing reservations, savings plans, making long-term commitments. These sorts of things allow you to reduce your bill. And it's first on this list because it has the lowest sort of impact from an engineering and architecture perspective. And you don't necessarily need to engage developers or application owners to apply a savings plan to an environment. So the complexity is a little bit lower, and you can do something like apply savings plans across your environment for a quick 30% plus haircut on your AWS bill, especially for EC2 or resources where savings plans apply. And so this is the most common approach we see when organizations are like, our costs are higher than we expected. We want to manage this. And so applying discounts on the top of it can just bring more consistency to your bill and kind of help with more consistent billing month over month. The next optimization method is deleting. This is the activity of going through your resources and cleaning up resources that aren't providing any value. So this might be unattached storage devices. This might be IP addresses that are not attached to any resource anymore and they're just hanging out. This might be full EC2 instances that are working on or were provisioned for a project that maybe doesn't exist anymore. Or maybe it was a test bed for a new idea, right? And these sorts of things can sometimes, I don't know, maybe the owner went on vacation or was assigned to a new project team or something like that. Those are obvious opportunities to delete and clean up workloads and resources that aren't providing any business value. Next up is right sizing. This one's my favorite. It's the most complicated by quite a margin. Picking instance sizes is fairly difficult. You have to evaluate what are the different performance characteristics of each instance family you have. And there's a large amount of different instance families, which is really valuable and helpful because some have much faster CPUs, some have GPUs, some have higher memory capacity. There's all of these new performance characteristics of pretty much every single instance family that can meet your needs more effectively. Yet selecting which instance size is right for every one of your workloads can be kind of daunting. There's just so many to pick from. And so right sizing and keeping those sizes in a healthy range can save a significant amount of cost and also improve performance as well when we pick sizes that fit better. Examples of that would be like, hey, I have a CPU intensive application. I'm going to move these to an instance family that has higher CPU capacity, right? Things like that. And lastly, suspending. This is the activity of turning things off. This is akin to turning off the lights when you leave the room. This one's difficult because there's a large behavioral component to IT where we're used to 5 nines and keeping things running all the time. So in the cloud, we have this new flexibility of being able to adjust our capacity levels on the fly, which is really powerful and one of the main reasons that cloud is really valuable. That kind of flies in the face of a historical IT behavior of keeping 5 nines and keeping everything running all the time. That was a fantastic operating model when the hardware was paid for and bought and paid for, and keeping the data center running was imperative. But for non-production workloads, whenever you have a stateful instance, like an EC2 instance or RDS even, or anything that is serving traffic in a non-production manner, when your engineering organizations are maybe in between release cycles, or they only work certain hours a week, say you have a certain geography that the engineering team all resides in, you can turn those non-production workloads off nights, weekends, or entire downtime periods between release cycles and save a fairly significant amount of money. And so it's, again, this cultural change of turn the lights off when you leave the room, and we can apply that in the cloud. So let's talk about how these optimization methods can stack up with each other. So say we are looking at a cloud bill. We layer discounts on top of it, whether that's reservations or savings plans or other bulk discounts or things like that. And then we apply scaling on top of it. So we right size all of the workloads, we pick the right instance types and sizes and everything. We get an additional amount of savings from correctly sizing our resources. Then we turn off our non-production workloads nights and weekends. And then lastly, we delete and continuously clean up all of the resources that do not have any specific business value at any given time. So when we talk about the total potential of optimizing your cloud environment, we're talking about a savings amount that can be fairly staggering. When we implement all of the optimization methods together, we can save a fairly significant amount of your spend, especially like, for example, on EC2, where all four of these can apply very effectively. Now, for those of you that are looking at the percentages and noting that they don't add up, this isn't a test to see if you're awake or not. When you apply discount methods together, there's a bit of overlap on the savings. For example, if you're applying savings plans across things, suspending them at the same time does still save a fair amount of money, but also has there's an amount of savings that overlaps between the two. So you'll notice they don't fully add up to what should be 75%. So be aware of that, and we'll go over that more in the next few slides. And another point about scaling is just when we move all of our workloads from on-prem, historically, typically IT has sized these workloads based on server lifespan and cost per lifespan. And so you might have like a 3 to 5 year lifespan on a piece of hardware you purchase for a specific project or program. And so when you're purchasing hardware on-prem, it makes a lot of sense to pay a little bit more money for a higher amount of memory capacity or CPU. It's a cheap insurance policy. For example, if it costs you an extra $500 to throw an extra stick of RAM in a machine that you're ordering, it's an easy insurance policy when you're looking at the expense of having something for 5 years and the risk of an application growing and having higher utilization over time. And instead of finding yourself in a situation where you have to buy new hardware halfway through the lifespan of your current hardware, which is a costly mistake, it's so much easier to over-provision and overbuy your hardware a little bit. Now in the cloud, that doesn't work. So this best practice on-prem of purchasing your hardware and over-purchasing it a little bit for safety and future growth potential and all of that sort of stuff, in the cloud is absolutely unnecessary because we can change the sizes of resources whenever we want. But when we lift and shift these workloads from on-prem to cloud, we're usually matching the number of cores, the amount of memory, or just moving it over. That means the average CPU utilization can be fairly low, and it means that we have a lot of opportunity for resizing. Like if you were starting a new role at a new company and your boss came to you and said, okay, you can have the 16 gig laptop or the 32 gig laptop. What would you prefer? Now, there's probably a lot of IT pros on the call listening in. We all want more memory and more CPU capacity because why not? Like you don't want to sit waiting for loading wheels or waiting for your Outlook to pop open or whatever the case may be. And so we always sort of index and prefer on higher capacity and higher performance. It's just sort of human nature. We don't want to sit here waiting and watching loading wheels. So this unfortunately applies at kind of a large scale across cloud environments, and so there's a large opportunity for us to go clean that up and do a bunch of right-sizing. So let's take a look at a specific example. Here we have a workload. This is a server. This is an M5-4XL. This utilization is actually not bad. This gets up to 25% on a daily basis, which is maybe a little higher than typical. Oops, I just moved my slide. Okay, so this is actually a fairly well utilized server, but we can still resize it. We can still downsize this server by looking at the utilization metrics and providing a recommendation for a size that would meet the performance needs of this application running. So if we were to resize this workload, we go from an M5-4XL to an M5XL, which would be a reduction from $660 a month to $140 a month. That's $520 of savings. Pretty significant. So right sizing alone has a fairly significant cost savings. But what about if we turn this workload off? Say it's a non-production workload and we turn it off between 9 p.m. and 6 a.m. We'll save an additional $52. And then vice versa, like if we did just suspension and not resizing, the suspension savings numbers would be much higher, because in this graph, you would see the coverage going up and covering a bigger portion of the graph. But all total, when you do these two optimization methods together, you'll notice we are now running this workload, which was costing us $660 a month. Now it's costing us $88 a month. We just saved 86% of the total cost of this individual workload. Okay, so I already know a bunch of chat questions are probably coming through. Hey, I can't suspend my workloads. You know, they're production, or I have maybe follow the sun engineering teams that are global, and I can't turn them off. Okay, great question. Oh, sorry. Here are 3 suspension solutions you can use today if you want to turn off workloads, nights, weekends, or in between engineering activities. Here are 3 great products. There's AWS provided EC2 suspension capabilities, there's Lambda Event Bridge, and there's a product called AWS Instance Scheduler. These are 3 great products you can use to implement to turn servers off and save a significant. So definitely, I'm going to leave this up for a couple more seconds so people can bookmark or screenshot or whatever the URL is here. And then let's get back to the previous question. So what if you can't turn off your instances? They're production or they're critical or something like that. So let's take the same instance. We have an M5-4XL. We can apply the same right sizing practice to it. So we still save that same amount of right sizing. And by the way, the right sizing algorithms we need to be using are performance focused and performance first with a hefty amount of buffer. So they're always safe to take. That means we can apply the same right sizing in non-production and production, because we care about the performance of even of non-production workloads as well. But then instead of purchasing or suspending the workload, we purchase a discount. In this case, I applied, I believe it was a 1-year savings plan. Interestingly enough, the savings is $52. The total cost of this workload is $88 a month. It just so happens to be the exact same cost. So we can achieve the entirely same amount of 86% savings when we combine resizing and discounting. Now, it still makes a lot of sense to do suspension in a lot of cases. If you can suspend more than 30-ish% of the time, it's more lucrative to do suspension. If you can't do suspension, using savings plans or reservations, depending on how long the commitment is and how much you can commit to, the savings amount will be variable there as well. But that's the approach to take. So it really depends on your environment and what risk and appetite you have for suspension. So let's talk about reservation and savings plans a little bit more. So we just talked about them a little bit, about just kind of shaving some cost off of your resources. But how do we do this? So to maximize savings, what we're trying to do is break up your usage in your cloud environment into 2 groups: predictable usage and volatile usage. Now, your predictable usage is the workloads that are always online, they're production, they're kind of never really changing that often. And we can see in your utilization metrics and your bill, this consistent and predictable usage over time. And then we have your volatile usage. That's maybe spinning up resources, doing a little test environment, or trying something out, or scaling an environment up and then scaling it back down. the best practice and the approach when we split these two buckets out and kind of examine them is to cover your predictable usage with aggressive savings plans and reservations. Now, 3-year discounts versus 1 year provide a significant improvement in the savings amount. What we're trying to do is cover the predictable usage with the highest amount of savings plan or reservation purchasing as we can. Now, volatile usage would stay on demand. So that's your opportunity for continued suspension and other optimization efforts as well, and keeping volatile usage down by doing cleanup activity. So how do we purchase these? We have strong guidance and advice on breaking up your savings plan and reservation purchases into smaller, more incremental sized discount purchases. And there's a lot of reasons for that. One of the reasons is you don't want to have a single savings plan to cover your entire company, because when it expires and all of a sudden your entire cloud bill might go up by a significant portion because it's uncovered for some amount of time until you can repurchase that savings plan, you might incur additional costs that are not planned for or expected. So a more consistent and reliable activity is to do smaller, more incremental. Maybe that's breaking it up by quarter or by month and purchasing maybe 1/12 of your capacity in a savings plan every month for 12 months. Now, your environment's totally fully covered and you don't have this fear of, oh my gosh, my savings plan is going to expire. What do? I have to repurchase. Is it the right amount? And I have to go do this analysis. And so when we break them up into smaller, more incremental purchases, it's not only easier to manage, it's also easier to get approval from your finance team as well on the size and amount of purchasing for your discount. And so we can slowly and incrementally do savings plans and reservations quarter-over-quarter, month-over-month, and build up a repertoire. It's also more flexible that way. Say you're buying a lot of reservations. When you're buying reservations, if you have certain smaller reservations that cover individual applications or teams, if those teams move to a different region or if they shut down or whatever, a smaller reservation is easier to apply to a different application or a different project or something like that as well. So we have more flexibility if we have a lot of smaller commitments to play with. Awesome. Okay, so we're going to talk about Compute Optimizer. We're going to switch gears a little bit here. We're going to talk about right sizing, the Compute Optimizer product's goal, how it was designed, how we think about right sizing as we build Compute Optimizer. So Compute Optimizer, the goal behind it is to match your resources to sizes that are the performance you need at the lowest possible price. Essentially, it's looking at all of the utilization values across your environment, and it's saying, what would be the workload size, the instance size, that would perfectly satisfy all the performance that it needs without spending more money than is needed. So we are attempting to lower costs and also at the same time improve workload performance. I'll give you an example of that. If you have a bunch of workloads on M5 or maybe M6, moving to a newer generation instance type can give you faster CPUs, say a newer generation Intel or AMD CPU, or say a Graviton. Moving to those new instance types with faster and newer CPUs can actually be a really, really large improvement to performance, even so much so that we might even be able to cut the number of CPUs down because the CPUs are faster per core. And so there's like a lot of opportunity here for us to improve performance and lower costs at the same time. Compute Optimizer applies insights for millions of workloads. This is our AI ML model that we use to determine all sorts of performance information on how certain applications work, the performance patterns and recognition of that. And that's all baked into our right sizing engine as well. And then of course, our goal is to save a lot of time because you don't have to individually go through every single workload and figure out, is this the right size, and do your own analytics and math and pull the historical utilization data and look at it and compare it against all of instance types. So we're trying to operationalize a lot of this for you and kind of do away with the amount of time and effort it takes for you to do the heavy lifting of picking the right instance size for every single workload in your environment. So here's a few screenshots of our console. Inside Compute Optimizer, you'll see right sizing recommendations for EC2, auto scaling groups, EBS volumes, Lambda functions, and actually something that just launched, which you will now see in the console if you have any Fargate resources, or sorry, ECS resources on Fargate. So if you have any container workloads on Fargate, you'll now see right-sizing recommendations for those containers. We're really excited about that launch as well. That came out just a few weeks ago. So another screenshot of the dashboard, you'll see that it'll total up all of the savings potentials for individual accounts. You can filter by region as well. This will give you a total understanding of how much savings is out there for each account. And then you can see breakdowns of the performance improvements that Compute Optimizer has detected. So if there's some workloads that have really bad performance and they're really struggling, you'll see those identified, and you can remediate performance issues before it becomes like a major incident or a ticket or getting called at 2 in the morning because you have a performance issue. Now, another really, really awesome product that we have is the CID, the Cloud Intelligence Dashboard. And there actually is a optimization dashboard within the CIDs, which is the Cloud Intelligence Dashboards. What this does is actually pulls all the Compute Optimizer right-sizing recommendations and aggregates them for you across all of your accounts for your whole organization. So you can track savings over time, potential savings for your entire company, and you can watch the number go down as your company achieves a lot of right-sizing success. So it's really cool to track your success over time with this dashboard. Okay, let's look at EC2 right-sizing specifically. EC2 right-sizing considers performance. And so it's evaluating all of the different elements of how a EC2 instance is built and how much performance it can provide. And then it's evaluating the utilization it sees out of your instances to pick the correct size. So here's an example, kind of small text, I'm sorry for that, but it shows you all of the utilization graphs, and then it shows you the different right size recommendations that you could pick, whether they are maybe same family, maybe moving to a different family, or a different processor model completely. For example, graviton recommendations. This is one where graviton can be a significant reduction in cost and improvement in performance. There's a lot of graviton instances out there now that have a lot of capability. And this is important to us because there's a lot of workloads you're probably running today that are already compatible with ARM64 and Graviton. So when you do have situations where you're considering optimizing by moving to Graviton, Compute Optimizer will give you recommendations. You'll see on this screenshot, let me wait for it to load for a second for y'all. You can pick if you'd like to see Graviton recommendations or not. And so if it's something you're interested in, if you feel like there are certain applications you are running that are compatible, or if you want to just see what the savings would be if you did switch resources to Graviton, you can check this box and see those recommendations. Once that's done, you'll see the individual recommendations to move to various Graviton instance types and the additional savings that you would achieve, which can be significant. So by default, EC2 recommendations use 14 days of historical data. Now, a lot of production teams or operations teams would prefer more than 14 days of historical data. So we have an option to turn on enhanced infrastructure metrics, which extends the amount of data that Compute Optimizer uses to generate a recommendation to 93 days. So it's designed to be quarterly. So any sort of quarterly cyclical pattern or usage that your applications have would be accounted in the right sizing recommendations to be even more conservative and safe and performance aware. EVS volume recommendations, this is storage. Now, this is important to us because storage is a fairly large part of a lot of organizations' cloud bill. There's a lot of great opportunities out there to optimize your storage. And my personal favorite part of storage optimization is you don't have to take any downtime, which is phenomenal because you're in the situation where it can be very difficult sometimes to schedule maintenance windows or talk to different engineering teams to execute right-sizing recommendations. But on storage, you can take these changes, these right-sizing recommendations, and no downtime needed, no change window needed, no planning, maybe no ITIL tickets or change management tickets. And this is another great opportunity to improve performance at the same time of saving cost. So for example here, you can move from GP2, actually this example is an IO1 changing the IOPS capacity from 500 to 300 for a cost savings, for a 38% reduction in cost. So we can change the amount of IOPS you have on each volume to save money. My personal favorite is GP2 to GP3. It's a 20% flat reduction per gig of your storage costs. And you'll notice on this screenshot, your baseline IOPS goes from 100 to 3000. So GP3 is quite a bit faster for the smaller drives because it has a guaranteed 3000 IOPS. And that's really cool because you run into the situation where on GP2, if you had IOPS performance issues, you had to increase the size of the drive. On GP3, you don't need to do that. So you get better performance and lower costs at the same time when you move from GP2 to GP3. So another feature we launched, actually we launched this at reInvent, for those of you that were there or have heard about this one. When Compute Optimizer has memory metrics loaded into it, the recommendations are much more higher savings. And that's because if Compute Optimizer does not have memory data, Compute Optimizer will not recommend downsizing memory because, again, back to our previous talk track, we do not want to harm the performance of any of your workloads. It's really important to us. So when we have memory data, it unlocks the number of instances that Compute Optimizer can consider to right size to fairly substantially. When you don't have memory data, the number of instances that we can consider to right size to is fairly limited to only instances that have the same amount of memory or more. So that limits the savings amount. When we have memory data, we see an additional several times higher amount of savings. And so we've launched an integration with 4 leading observability partners: Instana, Dynatrace, Datadog, and New Relic. And now there's a very simple way in the Compute Optimizer console to select which of these products you may have in your environment, to load the memory metrics into Compute Optimizer. And then you'll see in the Compute Optimizer console, an external metrics provider will be listed with the additional savings listed right next to it. And so you'll see the additional savings that's exposed because memory data was provided to Compute Optimizer. So thank you. I just blazed through a lot of content. Thanks for bearing with me. There's a bunch of useful resources here. We have some blogs. We have the blog post for that observability integration at the top, the blog post for ECS on Fargate right sizing, some getting started documentation or more information about Compute Optimizer, as well as the Cloud Intelligence dashboard link there. If that dashboard was interesting to you, definitely go check that out. It's such a great way to track your adoption and progress over time as you optimize. Now, with that said, I'm gonna ask Lisa to come back on and let's dive into some Q&A.
Hello. Oh, can you hear me?
Yep.
Okay, good. My voice was going for a second there. So we have got, thank you so much. We've got a bunch of questions in the background. I'm going to actually start with a more philosophical one first. It was one of our first questions that when you're talking about this, how do you think about optimizing cloud usage? Is it always in terms of cost, or are there other ways that they could be optimizing away from cost that should also be considered?
Yeah, I actually, personally, I'm not as much of a fan of calling it cost optimization. I like calling it cloud optimization because if we wanted to save a ton of money in our cloud bill, we would just downsize everything to a T4. Like, boom, tons of savings, great. Our environment is very cheap, but all your apps would fall over, right? You have higher performance needs than just burstable T4 instances. So what I like to think about it is more matching up what is the value these workloads are providing versus how much I'm paying for them. And those should be like a strong relationship between the business value of what those resources are doing and the applications that your customers and maybe your employees are using. And so that relationship is critical because you might have a situation where you are over provisioned and a certain application has just a ton of resources assigned to it. But from a business perspective, that's the right thing to do. So it's not always about just scraping every dollar you can out of your environment. It's about making sure the dollars match up to specific value. And so I like the term cloud optimization better because we're optimizing why we're in the cloud. We're optimizing the value of cloud, not just dollars. It just so happens to tend to save you a lot of dollars. So.
Right. Making sure you're getting the value for your money. So when we talk about that under-provisioned, over-provisioned, what does that actually mean? Is it CPU? Is it memory? Is it both? How does that fit together?
Yeah, it's usually CPU, but it can be anywhere. It can be storage under provisioning. So over provisioning means the size of the servers you picked are too large. Under provisioning means they're too small and you have some sort of performance issue or constraint, whether that's CPU, memory, disk, network, whatever that performance component is of an application or an individual server workload. And so it can be multidimensional. You might need more CPU and less memory. You might need higher storage and less CPU. It can be all over the place. And because AWS has spent so much time building all sorts of unique and interesting instance types, there are a lot of combinations of different amounts of storage and CPU and network. And we can find the right instance size for pretty much everything you're running, I'd say for everything you're running, because we've spent so much time building all of those different instance families. So having the correct amount of each resource type individually by picking the right instance that has that right ratio of CPU to memory or what have you. And so that's hard. That's hard to do manually. Like if you were to try to do that and get spreadsheets out and look at utilization data, it would take a lengthy amount of time.
Okay, so when we talk about right sizing for EBS, does that refer to volumes provisioned versus data, or is there something else? So we've talked about how that provisioned worked for CPU, for EC2 instances, but what about for those EBS?
So we're looking at two things. We're looking at IOPS and throughput, and they kind of have a relationship to each other because IOPS is the number of packets, essentially like it's this, where we try to break down every single input and output operation, and some storage devices have very large inputs and outputs, and some have very small. But generally, the more throughput, the more IOPS, and the more apps, the more throughput, except in some cases when you have really large IOs. Spinning disks is a great example of that. They might have really high throughput, but low IOPS. So we have an opportunity to optimize individually each one of those. For example, spinning disks and HDDs have higher throughput capacity and lower IOPS, and then SSDs generally have much higher IOPS in general. So we can optimize between the two. We can also, if we have certain situations where we need really high IOPS, we can go to IO1 or IO2 or IO2 Block Express, provision the right amount of IOPS to make sure you don't have any performance issues on your storage, and hopefully do it in a way that we don't over provision the amount of IOPS we need. So IOPS is really important. If you use up all of your IOPS, it starts what's called disk queuing. If your disk starts queuing, that means things are waiting. Anytime things are waiting to get access to data, you have a performance issue. So we want to avoid that. And that's a little bit different than throughput. For example, when you copy a file from one server to another, it's going to use all of the throughput available to it. That's not bad. That's not going to cause a performance issue. That's operating just perfectly. And so we have different sensitivity levels between IOPS and throughput, and we kind of think about them differently, but we optimize both of them together to make sure we're providing recommendations to configure each storage device with the right amount of IOPS and throughput for you.
Thanks for that. I'm trying to look through the questions. I know we've got folks in the back answering, so I'm just trying to pick some of those we might have already answered privately or in text just to see if there's some. There was one around scaling, auto scaling versus right sizing, and how do those two fit together?
Yeah, so that's a great question. Auto scaling scales in and out. It goes this direction. Basically, you're adding additional instances to an auto scaling group whenever utilization is very high. And that's great for applications that are designed to be able to take new instances on the fly and incorporate them into a cluster. So say you have like a load balancer with web servers, and say it's Black Friday or something and a ton of traffic is coming in. Load balancing or auto scaling groups would see high utilization and would start adding additional servers to your auto scaling group to serve additional traffic. That's great. A lot of applications are not designed to be stateless or to be able to add additional servers into the environment without any failure or breakage. And then right sizing is scaling an individual server up and down. So more CPU, more memory, more storage capability or whatever, or scaling it down to reduce the capacity of those things and save money. And so it's really not about adding additional servers or removing them. It's really about looking at the individual server and saying, is this individual server sized correctly? That's a better option for applications that are not designed with auto-scaling in mind. There's a lot of folks that use auto-scaling groups, but they have auto-scaling turned off, and they're just using it as a grouping mechanism to keep servers together and keep them kind of online and sized the same. So there's like different approaches depending on your application's architecture and the application's appetite for scaling in that manner. You can do both as well. Like there's some pretty cool ways where you can size up and down to individual instances and size in and out an auto-scaling group. That's a really advanced and cool way to have a very optimal environment that serves your needs. Because sometimes you'll have an application that's kind of wonky, and one server in the auto-scaling group is really heavily utilized, and the other ones are idle. And so you can size that one up and then remove the other ones, right? So you can do some optimization of auto-scaling groups that way too.
Yeah. So I know we've got a lot of questions, so I'm just going to answer this one that we've seen a lot in the background. But the slides, I think we've published the location for where the slides can be downloaded. This recording will be available on the same page actually where you registered as soon as we can get it out there after the call is over. There was a question about is there any cost associated with adding in those third-party vendors, the New Relic, Datadog,
great question.
Dynatrace?
We designed it to be free. I love this. I'm so excited. We were able to build a design that is really cool, where we worked with each one of these vendors to design a model where they push us the data. So we're not making API calls into their systems. We're not incurring API costs. So we're able to build this entire feature for free for everybody. So just super excited about that because I love saving customers money.
So when Compute Optimizer gives those recommendations, is there a difference? Like, what are the restrictions on those recommendations? Do they recommend changes of instance types, or is it recommend like even different services? Like you're doing it this way, maybe it should be another way. I mean, how aggressive are those recommendations?
Yeah. So that's a good question. I know. So there's a lot of folks that have asked, hey, would you recommend me use a different service and move off of EC2, right? Like what serverless technology stack would make sense, right? We don't do that today. We provide recommendations to change EC2 instance sizes to other EC2 instance sizes. Now we do recommend moving across families. So from an M family to an R family or a T family, different families like that. That helps us immensely because we can unlock a significant difference in CPU to memory ratio or processor model or things like that that can improve performance pretty drastically. Recommending moving to different service types is an architecture conversation. There are a lot of choices out there. Are you going to go containers? Are you going to go functions? Are you going to go, there are all sorts of serverless options. What strategy is your company thinking about for long-term new application development? It might not be EC2. It might, there's so many choices out there. It can be a little overwhelming to pick which sort of service type and architecture best practices your organization is going to standardize on. So we do not provide recommendations to move to different services because it's an architecture conversation. Some applications are better suited to, various database services we offer, and some are not. Some are maybe no structure, no SQL, no data structure type solutions. Not everything gets solved with SQL these days like it used to be. So there's a lot to it. There's having a quality architecture conversation is really important. And it's not something I necessarily want to automate because it's different for every application. It's something we have heard a lot of. We do get that request a lot.
Okay. Similar to that one, so we're talking a lot about this spinning up, spinning down, scaling.
Mm-hmm.
Regarding your reserved instance and savings plan commitments, how do you decide, or what factors should you take in deciding whether to buy a commitment versus doing an on-demand pricing? Like, where is that cutoff? If you know your usage is spiky, meaning that it's going to go up and down.
Yeah.
How do you decide what to do in those situations from a reserve instance savings plan?
There's a few different approaches to this, and it really depends on the appetite of the company I'm talking to, whether they want to go more aggressive and have a little higher savings, or be more reliable and consistent and safe and not find themselves in an overcommitment situation. Because that can be frustrating. I'll say this. If you have workloads that are not always alive or on, say they get deleted and rebuilt on a regular basis, or you turn them on and off, or things like that. If they get turned off or they are not alive for maybe 30% of the time, it's actually still cheaper to reserve them. You still get higher savings if you discount and buy a reservation for something that maybe is more flexible and dynamic. And that might sound like a little counterintuitive, but think about it. Like, if you're getting a 40% discount on these resources and they're online 70% of the time, you still save money. Now, it kind of trips a flag that a lot of companies look at, which is savings utilization. So reservation utilization and savings plan utilization. All of a sudden, utilization takes a little dip when that happens. And so a lot of people kind of get concerned. They're like, oh my gosh, we have unused RIs. It's actually higher savings amount to have a little bit of unused RIs here and there and cover a little bit of your spiky utilization. Not all of it, but I've seen companies with something like 85, 90% coverage, and they actually have higher savings, even if utilization sometimes takes a little bit of a dip. And so there's this concept where I've seen a lot of companies have a goal. We want 100% utilization of all of our RIs and SPs at every month, every quarter, every year. That's a fine goal. It's a very conservative goal. There's additional savings on the table for you if you also cover some of those resources that are not online 100% of the time. So just keep in mind, compare the uptime and the alive time versus the amount of discount. And if the discount is higher than the offline time percentage-wise, you should buy the commitment. It is a more financially advantageous decision. It might give you a little bit of opportunity where, hey, these RIs are sometimes not used fully. But what's interesting is they will automatically start covering other resources in your environment. And so a lot of times you'll actually notice you still get pretty significant use out of them. And so I am personally a fan of covering a little bit more than the safe, only consistent utilization approach. That being said, if you were to go use the recommendation algorithm in our products, the savings plan recommendations, it's going to recommend covering a super reliable and safe and consistent utilization in your environment.
Yeah, actually, that's one of the things we do talk about a lot, is figuring out what's that cost break-even point of, if I bought a savings plan, how much do I have to use in order to break even on my commitment? I'm not losing any money. Yeah. And anything above that is going to be saving. So where is that point in there? I know it can be scary to commit to a 3-year when you don't always know what's going to happen. But it's interesting. So we have a couple other questions in here. We've actually got a lot of questions in here, more than I'm going to be able to ask live, just to give you an idea. But there is a question about when, do you have any advice on the storage side? I know we've talked a lot about compute, but there's been a couple of questions around storage. What tools are available for monitoring storage? What other things might we consider in a storage optimization situation?
Yeah, so there's a few approaches there. So we talked about GP2 to GP3. That's probably the easiest, lowest hanging fruit in the storage space. There's also, you can also evaluate and take seriously whether some of your storage devices should be on HDD, whether that's SC1 or ST1. When you analyze your environments and look at IOPS utilization across all of your storage devices, you'll probably find a significant portion of storage devices that just sit mostly idle and don't get reached out and touched very often, right? Information is not coming off of those storage devices very fast or often. Those are great opportunities to move them to SC1 or ST1. They still have decent performance, performance faster than any of our work laptops, so performance is still okay, it's not bad, and they're significantly cheaper. So looking at using SC1 and ST1 is a great way to optimize. I personally use all the CloudWatch metrics because it does capture IOPS and throughput and some of that stuff. There are other third-party right-sizing products out there that do look at storage as well. I have a personal few favorites. Probably won't share those on the webinar, but there is a lot of storage optimization potential. I also say like IO1, IO2, and IO2 Block Express. That is such an easy place to save money because they're more expensive, they are much higher performance, and tuning the IOPS capacity to what you need can be very lucrative financially because IO2 specifically and Block Express, the amount of IOPS you can provision there is eye-popping. It's crazy what they've done, what that team has done as far as providing insane performance levels. But that means we get to pick how much IOPS we want to provision in our IO2 devices. And IO2, the IOPS costs can be pretty expensive. So even minor adjustments in your IO provisioning can be pretty good savings. So those are the areas I'd look into. I would probably start with GP2 to GP3. And storage is one of my favorite optimization areas, again, like we talked about earlier, because there's no downtime. It's super easy if your organization is not ready for optimization to just start with storage optimization because nobody sees any downtime. Nobody gets frustrated and says, you took my server offline. And so there's just less waves made in your organization.
Yep. And then I'm just going to put in a little plug because I asked a question that was more IOPS MB megabytes focused, but also for S3, there are storage recommendations. Trusted Advisor has other recommendations. There are other tools out there that provide feedback on other services on how to manage them. We're almost out of time, so I'm probably going to only be able to ask maybe one or two, maybe two questions. But one of them that I want to address is, we talked about, looking at graviton and switching to graviton as an easy change. Mm-hmm. How often should you evaluate new CPU technology versus existing? I mean, what's a cadence that maybe, like we talk about, like, I mean, the amount of what's new posts that come out of Amazon is insanely high, and it's hard to keep track of all of that. How often should you be looking at that? Or what trade-offs should you be taking into consideration when you look at that?
I don't know if there's like a perfect answer to that one. I look at it all the time because like I like building computers, so I'm always like paying attention to the latest processor launches, and AWS does a great job of launching new instance families pretty rapidly after a new processor technology is launched from Intel and AMD and Graviton, our own processors. But like, for example, AMD's latest Genoa processors are like incredible. Whoa, wow. I mean, those things have a significant performance improvement, and the number of cores they pack onto a single chip is incredible. And so when that thing came out, I'm like, oh my gosh, I gotta like look at, when does an instance family come out for this? How can I personally migrate my own resources over to it? Like, how can we take advantage of this? Because the price difference between AMD and Intel is there. The performance difference is there. AMD's done a significant job making some progress on their performance of their chips in the last like 5-10 years with the Ryzen platform. So I personally look at it all the time because that was like total, personal nerd about it. But I would say just pay attention. A more general answer would be like pay attention to the new launches. When you see a new launch come out with new processor types and you see announcements like 34% performance increase, right? Like go look into Compute Optimizer. If Compute Optimizer is like, hey, you should move all these to this new family, you probably have a situation where you're using older chips that are less performant.
Yeah. So your advice would be kind of keep an eye on it in terms of recommendations. If you can't always follow the what's new post, the Compute Optimizer is going to kind of give you some heads up on it. And I would also say that depends on your life cycle. Like when you're going into a new project and you're starting a new version, thinking about it as part of your design, what's going to give me the most flexibility in the future, so that if I want to change and take advantage of new technology, trying to think about that as part of the architecture. It's hard to not optimize for the chip you have, but to keep that in mind, because it'll give you an option for changing later too. We are just at the top of the hour, so I'm going to actually go ahead and say thank you so much, Rick, and I'm going to do the closing out of the session. We will be back again next month talking about managing and controlling your cloud costs. We also next week have the Cloud Financial Management Peer Connect, where we're talking about implementing forecasting for your program. So, and one of the actual speakers is going to talk about what happens when you optimize above your forecast, and now you've got a commitment possibly that is exceeding. We talked about this a little bit with the RI and a savings plans option. But how do you do forecasting then? And then I think someone asked in the questions and answers about the keys to optimization Twitter show. Those are every Thursday. Thank you so much. And we hope to see you again next month, and we hope this was useful. Thank you. Bye.